Hi everyone, so in this video I'm going to talk about basically how to solve a Leetcode question, which is basically a popular, very popular and common interview question you can find in Leetcode. Maybe this is the first question on Leetcode. We will do some problem. We'll do the first of all we do the brute force solution. We'll see the brute force solution for this, and then we'll go to the optimize how to optimize this optimize the solution through the some kind of like data structure to use to like optimize the solution. So let's get started with it. So let's see the problem in the lead code. Okay, so here's the problem. Here's the two sum problem. So here's the two sum problem. So what it says, given an array of integers numbers and an integer target, return the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. There's no restriction in the order of the how we can return the index of the elements. So let's see what is saying. This is what is the question is about. If you didn't understand it, let us see what the question is saying. So the question is saying the two sum problem. Two sum problem. Okay, so in the two sum problem, it says we have a list of integer numbers. Like we have, suppose we have a nums array and we have a list. Suppose here's given example 2, 7, 11 and 15. 2, 7, 11 and 15, and here's we have a target is given 9. Okay, so it says is there any two numbers in this list? In this list, is there any two okay, just move it. Okay, so in this list, is to have any two numbers that can add up to 9. You can generally see we have a 2 and 7 here that can add up to 9, right? So the answer would be the its output would be basically output would be its indices, not the elements itself, but its indices. Like we have indices like 0, 1, 2, 3, right? So in the answer would be, its answer is 0 and 1. Okay, so that is what it says. That's the definition of the problem. Again, if you see another example, if you have another list, like if you have another list nums, and we have another list like here is given 3, 2, 4, 3, 2 and 4, right? And we have a target is 6. Target is 6. So how basically we would get 6? We would get 6 by 2 and 4, right? Or 4 and 2 in any order. So the indexes indexes is 1, 0, 1 and 2, right? The output will be, so output will be, there is an array of two numbers, so basically the indices of the elements which sum up to the target, and it is basically a 2 and 4. That means 1 comma 2. This is the answer for this. This is the output for this like for these two inputs. Okay, so let's see the brute force solution for this, how to solve this. And okay, let's see the brute force solution, and then we'll talk about this time complexity as we always did. Okay, so let's see about the brute force solution. Okay, so brute force solution. Okay, brute force solution. Brute force solution is the solution which is not basically you are making solution which is not bothering about is how optimized it is. You just going through it and without any optimization, without any bothering about any time complexity, space complexity. You're just doing the getting the solution, getting the correctness, and then after getting it correct, after getting our answer correct, we will then deep dive into the optimization. How can optimize the algorithm? How can optimize? How I can basically we can optimize our this brute force solution. Okay, so what we can do in the brute force solution? In the brute force solution, we'll take two pair of elements at a time, like two pair of numbers at a time, and we'll sum up those numbers and we'll check if those the addition of these two numbers will give us the target. If it does, we'll just return the index of the basically index of the those two numbers. And if it doesn't, if the whole list doesn't contain any two elements that can add up to the target, then we simply return -1 and -1. So let's see how you can do that. So in this case, suppose we have a list. Suppose we have a list, and that is this one. Suppose we have a 3, 2, 1, 4. 3, 2, and 4. Okay. So what I can do will uh, like take the first element and we'll take the second element. First element and second element. Now we can add up this two. We can add up this to 3 plus 2 is equal to 5. Okay. 3 plus 2 equal to 5. 5. Now we'll check if it is equal to that our target. What is our target here? What target is here? Here I am writing our target is here 6, right? So is it equal to 6? Okay, is it equal to 6? Is it equal to 6? If 5 is equal to 6, no, right? So it will go to the next element. It will check with the next element. So it will just do 3, 2, 4. Now it will take the first element and will check with the fourth element. So what it will do? It will 3 plus 4 is equal to 7, and will check if it is equal to 6. It is equal to 6. Basically it is not. 7 is not equal to 6. Then it will this index, because we are at the last index at the end of the list, so this position will be incremented. This suppose like this, suppose this is I, this position indicates I, this position indicates J. So J will be increased. Suppose I equal to here, I equal to 0, I equal to 1, right? Or you can say J equal to I plus 1. So J equal to 1, so it will be incremented. Now it will be J equal to 2, here J equal to 2, here it is I equal to 0. Now I'll be incremented by 1, and I'll be in this position, means 1 position. That means we have a 3, 2, 4, and I, now I equal to 1 and J equal to I plus 1, that means it is equal to 2. That means this index will now point to this index. Okay, this is positive distance. So now 2 plus 4 is equal to 6, and it's also equal to 6. This is also equal to 6. So we get the two indexes I and basically 1 and 2. That means I and J. So now we can return. So we get the two elements. So we can return this indexes. That means my answer is I comma J. That means 1 comma 2. That's how you can get that. So okay, if you can't see it, now you can see, I guess, right? Now you can see that's how we get it. So I'll be I equal to 1, I equal to J, these two will sum up, we'll get 6, and it is equal to the target. Since it is equal to the target, we'll return I and J. Okay, so that is the brute force solution. Basically it is the easiest solution. So after okay, we can also see the time complexity here only. Okay, you can also take the time complexity here, or also we can go, first of all we can do the code, and then we can time complexity. I think that would be better, right? That would be better. Let's jump to the code. basically here's some constraints also. Here's your constraints. Constant does matter, but in this case it doesn't, because all things will be taken care. It's only valid. It says only one valid answer exists. No two answer can exist. Okay. Okay. So let's quote the brute force solution. Suppose we have, first of all, we are doing the brute force solution. Okay. Brute force solution. Brute force solution. So this is the Leetcode. If you don't know what is Leetcode is, so basically Leetcode is a coding practice platform where you can get lots of questions and you can do it to improve your skills, increase your DSA, like DSA skills, and like you can also do the questions in a basically section wise, like the for algorithms, for data structure, particularly for linked list, particularly for stacks, particularly. So that will help you if you are new to it, and if you're not new to it, then of course you already know these things. This is the case. Now let's go to the brute force solution. So here we have a solution class and we have a like function to sum, where we are returning in basically array. We're getting the nums array, and we're getting the target element. So let's do the outer loop. I'll explain it after the code, after I wrote it down. Yeah. So this is the what do I don't write? I think here. Okay. So int I equal to 0. Uh, I is less than nums dot length plus plus the inner loop, so 4, and so if you can't see it, I'll increase the font size a little bit. 18 is good. Yeah, I'll close this a little bit so you can see it correctly. Yeah, so that's so for end j is equal to I plus 1, and I have j is less than nums dot length. Okay, j is less than nums dot length. Yeah, that's what we want. Basically we don't have to go to the last element, so we can do it minus 1 times, and we'll do j plus plus. Okay, now let's say if nums I plus nums j can sum up to the target, then what we'll do, we'll return it. Return new array with the elements I and j. Okay, and if we cannot find any two elements we can sum up to the target, then we return an array with the elements -1 and -1. Okay, so let's run it. Accept it, submit it. Yeah, it's accepted. So you can see it don't have a good time complexity, but it does have a good space complexity. So that's is good. That is pretty good for the brute force at least. And since we have done the brute force algorithm, so let's see the time complexity for this. Basically, it is simple. Let's explain the code. So for I equal to 0, this is that for I equal to 0, and I is less than nums dot length -1. So it's for the outer loop. How many times? Basically, it is for the iteration. This iteration it is for the I. I is going step by step, and it will go up to the n-1 times. That's why it is ar at nums dot length -1. And in case of the j, it will check this particular thing will check with this. This particular thing will check with this. This particular thing again check with this. This particular thing check with this. So it is basically decreasing because it is from j plus 1. It's basically decreasing in step by step manner. So so basically you can now we'll see the time complexity how it works. This is the time complexity. Okay, let's see the time complexity. Okay, time complexity. Time complexity for the brute force approach. So what is time complexity? So in this case, uh, what we are doing actually, uh, basically for the outer loop is running n minus 1 time, right? And for the inner loop, for the j actually, for the inner loop, for the inner steps, but it is basically decreasing. For this one, first of all, it has to do two steps. It has to do one step. Okay. First of all, it has to do two steps, and then it will do one step. Basically, 2 plus 1. So if it has basically there's a 3 elements, that's just 2. So if it is a n steps, then what will we do for n steps? We 1 plus 2 plus 3 up to n minus 1. This will be right. And we know the Sn formula, that is the first element plus last element divided by 2. Right? So 1 plus the last element, first element plus last element divided by 2, it will give us n upon 2. So we have an outer loop and the inner loop. So the total steps we need for each step, we have n upon 2. So for n minus 1 step, we will multiply this 2, right? So the total steps actually, so total steps is basically n minus 1 times n upon 2. So it is like the selection sort algorithm, right? So n square upon 2 minus n upon 2. So we're cancelling the less important terms, and so time complexity will become n square, big of n square. And space complexity, since we are in this brute force approach, since we are not using space complexity, since we are not using any extra spaces, extra auxiliary spaces, so its space complexity is big of 1. It's constant space complexity. Okay, it has a constant space complexity, and that's why basically its time complexity is basically a little bit worst in this case, and space complexity is good enough actually. That is the brute force approach. Now let's see the optimized approach for this. Let's see about the optimized approach. How to optimize it. Optimized approach. Optimized solution, you can say. Optimized solution. So for the optimized solution, uh, what you can do, optimized solution. So we have a list of numbers. Basically, let's take the first list. What it take in the brute force solution. So 3, 2, and 4. 3, 2, and 4. Okay, so in the optimized solution, we'll use a data structure which is really hash map. In this case, we'll use hash map for optimized solution. Hash map. How will you use it? Let's see about that. So we have a target. In this case, we have a target. Target of 6. We have a target of 6, right? So what you can do? What you can do is basically we are the step 1. We are just going through the loop 3, 2, and 4. Right? Let's do it in the next page. 3, 2, and 4. We have a 3, 2, and 4, and we have a target of 6, right? So we take the first element, and what we'll do, we'll minus it with the target. That means 6 minus 3, we'll get 3. We'll check if 3 is in the hash map. So here, suppose we have a hash map. Suppose we have the hash map, like we are making it like this. We have the hash map like this. We have a key. Suppose in the hash map we are storing key and value pairs. Key is basically key and index pairs. So 3 is the value. So we'll see is for now the hash map is empty. So we'll see if 3 is exists. 3 is the key in the hash map. Is it the keys? The whole thing is empty actually. So whole hash map is empty. So let's say no, there is nothing, no keys in the hash map. Now so it will go to the next index. Will be 2. Next index 2. Basically it will store now. When it's going to the next index, it will store the 3 in the hash map. 3 is my hash map. That means 3 will be stored here with the index, with its index. It is 0, right? Basically it is in the 0, 1 and 2. That means 0. Now what it will do, it will check if 2, basically 6 minus 2, if 6 minus 2, we have 4. If 4 is in the hash map, no, it's not in the hash map. So what to do, 2 will be stored here, 2 will be stored here with the index, and it will go to the next index. Okay, it will go to the next index. So when is an index, index number 2, so it will again check 6 minus 4 is equal to 2. Now we'll check if 2 is in the basically hash map. We'll say yes, it is in the hash map. When it says it is in the hash map, so we'll return this index and this index, this index and the current index. So what it will return, so the output will be, in this case output will be 1 and 2. So it returns the 1 and 2. Okay, it is in the 1 and 2, but without this for basically the brute force solution, it has to go to lots of steps. It will go to lots of steps. But in this case, it does not have to go to lots of basically lots of steps. It does have to go to the n steps. 1, 2, and 3. 3 elements, 3 steps. That means n step. For L elements, it will take n steps, right? So there is the basically very optimized solution for this. Although it don't give you a very good space complexity, but it does give you a basically very good time complexity. So let's see the code for it, and then again I will explain a little bit if you don't get it. Okay, so let's go to the code and just do the optimized solution for this. Let's comment it out. Okay, let's comment it out and the optimized solution for this. Okay, let's copy it again. Optimized solution. Optimized solution. Okay, this optimized solution. Just yeah. So I'll be delete it. So I have to do. I have to iterate n times, right? And I equal to 0. So we have to create a hash map generally. So we have to import it. The hash map is in the java.util. Java.util hash map java.util.package, and hash map is the class. So we will use it. And if you don't know what is a hash map, is having the data structure, and we'll cover it how hash map works, what is the basically the all things about hash map, how to use it, the functions of hash map, different functions of hash maps, and we'll see basically we'll see hash table actually. It is a data structure actually. So we'll see it. For now we'll use the pre-made class of Java, which is in the java.util.package hashmap. Okay, so we'll use this class in our solution. So how can we use hashmap integer so like we're using hash t, suppose this name, it can give you anything here, and hash map. So if you can't understand anything here, so you don't have to bother about it, because of course I didn't teach it, but I will teach it in the when I'll do the data structure up like course, then I will teach all the things in those in that course actually, so you don't have to bother anything about it. So integer hash t new hash map. Basically, you can think of hash map as like a table of rows and columns where basically of a dimension you can say multiple rows and two columns you can say. So in one part, basically one column you will store the keys and one part you store the values. Okay, it's like this. It's like if you have to draw it, it is like this. Okay, it's like this. So here we'll store the keys. Here we store the values. Suppose it simply you just assume this 3 0. If you insert these things here, it'll be 2 1. Okay, this is the simple explanation you can say. Okay, so now we'll iterate n times arr dot length I plus plus. Okay, just give a minute. Yeah, now what will check if the what will key will generate, like how you can generate the keys by subtracting the target. Here's a target, there's a target, right? Target minus the current element, target minus the current element. So target minus the current element, the current element equal to key actually. Okay, so I will do target basically target current element. So we'll check there's a function in hash map. uh, there's a function in hash map which is called contains key. So it basically contains key uh, that will check if the key exists in the hash map or not. So it will be target, it will be target minus the current element. Current element is ARR of basically not ARR here, it will be nums, right? Okay, it will be nums. So here also it will be nums. It will be nums. Okay, so target minus this one, and if the key is there, so what it will do? The key is there, like if the key is there, if the key is there like this, so we'll return the value of the key and with the current index, the current index. What we'll do, return new end and with the value of the key. So the value of the key will be, we'll use the hash maps get function. Not the hash map actually. Okay, it's not hash map actually. The name of the hash map is hash t, right? Hash t. Mistake, silly mistake, you know. So it will be hash t dot get, and we'll do target minus nums I, and here we'll do I. We'll return this to elements. This is the index of this is the basically value of the key, and it is the current index, and we are storing it, and we're storing it. And if it doesn't, if it doesn't gets the key, so what it'll do, it will store the current basically current key. What will get the current key in the hash table. So what we'll do, hash t dot put first of all we have to give the key and then we have to give the value. So put uh, key, so key is basically target key will be nums I. This is the key, and this is with the value, the index index with the value. And if it doesn't work out, so new end, get the minus. If nothing happens, if there's no combination which can sum up to the target, then we'll return -1 -1, right? So let's run it. Hopefully there will be no error. Yep, it's accepted. Now we submit it. Yep, we got it. You got it. So basically it is 99.38% and it is 65%. That basically the the time complexity increased like in a huge amount. Is 99.38%, and space complexity is quite good. Not that good, but it's quite good. So let's explain the space complexity of this, the time complexity of this algorithm, the optimized algorithm. So this is straightforward. We use an iteration n times, and the length of the nums, length of the list n times. So it is straightforward. This it's time complexity. It's time complexity. What is time complexity? Can you tell it? It is big of n, right? And if it's about the space complexity, it depends. Actually, the worst case, in the worst case, the space complexity will become, because we are storing it, right? So the worst case, the space complexity will become the length n minus 1. Okay, suppose we are getting it in the last part. Suppose in this case, suppose we have a, the length is n, and we have a, basically then this 3, and we are getting a length of the hash map of 2, so it'll be n minus 1. So the space complexity n minus 1. That means if you remove the constant parts, it will be n. So the space complexity also became big of n, right? So that is the time and space complexity of the optimized solution. Okay, so that's the whole so like video for this like two sum problem solution. Hope you like it. If you like it, you can share it with your friends. You can like share it in Twitter, in LinkedIn. You can take a snapshot and basically uh, learn in public. If you are interested in learning in public, then you can like take a screenshot and share it in Twitter and LinkedIn. That'd be great. I'd be happy. And in the future videos, I'll be doing like interview questions of Facebook, Google, and Amazon. So do subscribe my channel. Uh, so that's it for today. See you in the next video.